Hi, and welcome to our 5th episode of the Science Lesson Support System, suitable for primary school from ages 6 to secondary and right through to long life learners. In our last episode, we covered sound and air and how these simple little resources can help add connectivity to all of your existing STEM lesson plans. Today, we are covering electricity and look at how this support system adds connectivity to all other areas of science and nature, allowing for a better integration of topics and differentiation for students. So let's get started. Electricity is the flow of electrical power or charge. It's a secondary energy source, which means that the planet gets it from the conversion of primary sources of energy like coal, natural gas, oil, nuclear, or renewables. Electricity happens when electrons play a relay race with their free spare electrons, also known as valence electrons, all within a conductive metal wire or conductive object. But materials that electricity cannot pass through are called insulators. And insulators simply are made of atoms that do not have any spare electrons to play a relay race with, so it cannot conduct any charge. It has to be a joke or a pun in there somewhere. The flow of electricity also affects the invisible electromagnetic field outside the wire, which is just as important for electricity to flow. Electricity and magnetism are essentially two aspects of the same thing, and we will touch on this in our next episode on magnetism, episode 6. But of course we do, because atoms and molecules can overlap everything, because atoms are nature's Lego. We have tools to interact with this invisible force like clamp meters, all without touching the wire directly. So let's build our conductive metal wire display with some metal atoms. As explained in previous episodes, each colour is an element, but all are atoms. The silver atoms can represent any metal you want. Looking at this image on conductive materials, we are choosing copper, because most wires you'll find are made of copper. First, let's build a resource to share with other classes throughout the school. And all you need is a handful of silver coloured atoms, some electrons, and as many as you like. Okay, nature always reuses its atoms. And when atoms make friends and hold hands, they form a molecule. So we just simply keep adding on electrons and atoms, and voila, you now created your very own basic representation of a copper molecule demonstrator. Okay, we now need something to glue our conductive molecule to, and preferably something with some explanatory detail in it. So let's Google the keywords electricity atom. Click images. Find the one you like. This will also open a related image box. And just have a nice look and decide for yourself. We went with this one, which is nicely descriptive. Right click and just save to PC. So we want our molecules to match up in size with our photo when we print it. I'll show you an awesome hack for this that can be applied to anything you print out. Simply open up Word, hold up an A4 sheet portrait up to your screen, and on the bottom right hand corner, just zoom in or out to match the screen to the page. That's about good enough. Now that your page is the same size as real life, come along with your molecule. And when you hold it up, the page that you print out should match this real molecule. So what we can do now is we can drop our image in. I'll just twist it around. And now what we can do is pull the image in and out so we'll match the molecule to the picture. When you're happy then, just hit print. We then suggest laminating for durability. Now simply grab your hot glue gun and dab each atom and then set down your real molecule on top of each atom. Don't panic about the excess glue, just let the stringy excess glue completely dry before removing, otherwise you might risk smudging. And congratulations, you now have a lifetime resource. It was worth it. This will benefit your whole school and thousands of students over the future to come. We can also do a fun classroom exercise as well, making a conductive material. All you need is a handful of these silver coloured atoms. You can either do this for each student or as a group project if the silver coloured atoms are in short supply. Simply connect the atoms together using electrons just as we did earlier. We can now take some electrons out of the box and use our imagination and zigzag the electrons in and out each atom in one direction just to simulate the flow of electricity. This is called DC current or direct current. But in AC current, however, the electrons go forward and reverse, then go forward and reverse over and over. And this type is typical in a domestic home. Thomas Edison advocated for direct current, while Nikola Tesla, on the other hand, was in favour of the alternating current. But both types have their uses. To simulate AC current, the students could use thread to tie electrons together and then pull them back and forth to simulate the oscillating current. This is simple enough to get the concept across at primary level and will instill a basic but deeper understanding of not only how electricity works, but why electricity works. To build the AC molecule, we recommend first placing the electrons into each atom all the way down. Then take some white thread, or ideally some clear fishing wire, and tie the fishing wire around each electron all the way down. And this way you can keep each electron at the same distance as each atom. And once you have a good sturdy double knot on, you can pull out each electron. This will link into all of the other resources and topics we will be covering over this whole series, because atoms are nature's Lego. Static electricity really reminds us how nature loves to reset a balance, and also easily explains through atoms and molecules that when we rub materials off one another, the action means that we added energy into nature. This action can sometimes make electrons jump from one material's atoms to another material's atoms. But of course, nature loves balance. And in science, we call this balance equilibrium. So in touching something like a car door or your house door, you can get a zap. This is nature returning its electrons, resetting a balance, and returning to equilibrium. We can role play this action by getting students to hold two spare electrons as if they were in balance. Then they can rub off a molecule so their electrons leave the student to join that molecule, and the student is now positively charged or open for electron business. The student can then touch another molecule just like a doorknob, pretend to get zapped, and take two of their electrons back. As the doorknob was negatively charged and the student was positively charged, they're now back in balance. So just remember the 4 basics by hitting pause on the video. And next time we will be taking a look at magnetism and how atoms and molecules can help explain this too. Well, that's it for today. Thank you very much for joining us. I've been your host, Paul Brereton, and remember, you're not just teaching STEM, you're telling a story, the true story of nature.